Okay, so where we ran out of time, we were just solving here. So bring your negative and your AY over, bring your VI squared down, and you're left with 2 sine theta cos theta, which of course you're going to substitute for sine 2 theta. So sine 2 theta will equal negative 9.81 meters per second squared. Delta dx is 2 meters, and VI was 7.5 meters per second. And don't forget to square it. If you do, you'll get an error, and then you won't know what the heck's going on. So sine 2 theta ends up being 0.3484. So 2 theta ends up being 20.39 degrees, because you do inverse sine of both sides. So you get a theta of 10.28 or 29285. And then remember, subtract that from 90 to get your second one. So 79 point, I said 28, but that might be 10.21, sorry, 1. And so then this will be 79.79 or something like that, okay, for your 2 thetas. And that's it for that one. All right, then I asked you to do 13 and 14. So 13, at Halloween, a witch launches herself on her broom, of course, from the edge of a cliff. So going up, coming down, this is the edge of the cliff, 140 meters tall. Angle is 36.87 degrees. VI is 100 meters per second. Throckmorton and Warburton are walking. She launches herself. A do-gooder physics student knocks her unconscious, and that's so she becomes a projectile, in case you were wondering why that was there. So VIX is VI cos theta, which we can find. AX is 0. One of the questions asks for delta dx, and another asks for delta t. In the y direction, VIY is VI sine theta, and it's up. We can find it. AY, 9.81 meters per second squared down, and delta dy, 140 meters down. And we don't know delta t. So again, quadratic to find the time. So delta dy is equal to VI sine theta, delta t 1/2 AY delta t squared. So the 140 goes in as a negative because it's down. 100 meters per second, sine of 36.87 delta t, plus 1/2 negative 9.81 meters per second squared, t squared. Rearrange, so it's going to be 4.905 meters per second squared, t squared, minus 36.87 is 0.6, and the sine of that 100 is 0.6, and then times 100 is 60 meters per second delta t, minus 140 meters equals 0. So delta t equals negative 60 meters per second, plus or minus square root negative 60 meters per second squared, minus 4 times 4.905 meters per second squared, times negative 140 meters, divided by 2 times 4.905. Okay, so delta t equals 60 meters per second, plus or minus, under the root is something that I didn't write down, over 9.81 meters per second squared. So you end up with 60 meters per second plus or minus 79.79 meters per second over 9.81 meters per second squared. So 60 plus 79.79 meters per second over 9.81 meters per second squared, and the other one is going to be 60 minus, and obviously that one is not going to be useful in our lives. So we're not using that one, we're using the first one. And when you do the math, you get a time of 14.27 seconds. Okay, so you now take that back here and fill it into delta dx is equal to VIx delta t and all this jazz that goes to 0. And so you get delta dx is equal to 100 meters per second cos of 36.87 times 14.27 seconds. And you should get a delta dx of 1,139.62 meters. Okay, so that's two of the three things. Velocity when she strikes the ground. So you need her VFX, which is going to be equal to her VIX, which is just 100 meters per second. Cos of 36.87. Cos of 36.87 is 0.8. VIX is 80 meters per second. VFX, excuse me. And VFY is what was under the root. So it's 79.79 meters per second. And it's just a coincidence again that they're so close again. The last one we did was 2. That's just because I like picking 53 and 36 as my angles. VF and theta. So square them, add them together, take the square root, and you should get 112.90 meters per second at an angle of 44.98, I think it is, 44.98 degrees WRT ground. Okay, that was number 13. Number 14 says, in a faculty versus grade 12 baseball game, a famous teacher hits a home run over a 12-meter high fence. So it's starting lower, going up, clearing a fence, 12 meters high, 100 meters from home plate. What was the minimum speed if the hit was 1 meter above the ground? So this is 1 meter here. And the angle was 40 degrees. So in the x direction, VIX is VI cos theta. Can't find it because we don't have VI. Delta dx, though, is 100 meters. AX is 0. In the y direction, VIY is VI sine theta. Going up, can't find it, don't have VI. AY, 9.81 meters per second squared down. And delta dy, got to do a little math there, 12 minus 1, 11 meters up. Two equations, two unknowns again. Delta dx is equal to VI cos theta delta t, and the last term goes to 0. In this equation, we don't have the VI or the delta t. Delta dy is equal to VI sine theta delta t, 1/2 AY delta t squared. Again, don't have the time or the theta. So rearrange this one. VI. Rearrange this one for the VI. And it's going to be delta dx over cos theta delta t. And sub it in for the VI over here. So delta dy is going to equal delta dx over cos theta delta t times sine theta delta t, 1/2 AY delta t squared. So it's going to be that tan theta one again, right? The t's are going to cancel. Delta dy is going to equal delta dx tan theta plus 1/2 AY delta t squared, and now rearrange for t squared. So t squared will equal delta dy minus delta dx tan theta, and then you have to multiply both sides by 2 and divide by AY. So t squared is equal to bracket 11 meters minus 100 meters tan of divided by negative 9.81 meters